57 is where we're starting, right?
Yep.
Okay.
You said you wanted to start.
So 57. 57 says, for reaction A to products, successive half-lives are observed to be 10, 20, and 40 minutes for an experiment, where A naught equals 0.1 molar. Calculate the concentration of A at the following times. So the first thing I have to do is figure out what order is this. So you would agree that my half-lives are doing what? By what factor?
Double.
Yes. My half-lives are doubling. Right?
Yeah.
And so if my half-lives are doubling and my concentration is being what? It's as my half-lives double, my concentration always goes down by a half, right?
Mm-hmm.
Okay, so concentration goes down by a half. Okay, so which order is that consistent with?
0.
That's second order, right? That's a second order reaction. So that is a second order reaction.
How do we know?
How do you know?
Yeah.
Well, you could look at the graph that I gave you. So the graph that I gave you would really help you on that. Because, yes?
So 0 order molar doesn't change. First order it changes the same amount, and then second order it changes to the square, right? Because that's why there's exponents.
Well, first order has nothing to do with concentration at all,
Half
right?
first order half-life is constant, and then for zero order the half-life gets smaller.
Oh wait, so am I not? I don't think I'm talking about rate then.
I think you're talking about rate. So look at your half sheet. That's what I would have done to figure out that that's second order. Not your half sheet, the whole sheet. Sorry, the whole sheet with the half-lives. Wow, that was a lot. The whole sheet with the half-lives. Yes, that's right. So that's second order. So that is part one. After you figured out second order, then you can use your equation for second order, which is T 1/2 is equal to 1 over K times the concentration of A naught. That is the equation for second order half-life from my half sheet now. Yes?
Mm-hmm. Yep.
Okay. So, if I need to solve for K, so if I rearrange for K, I'm just going to rearrange. So K equals 1 over T 1/2 times concentration of A naught. I have all of these numbers on 57. So K equals 1 divided by my half-life is what? 10 minutes. My half-life is 10 minutes. And I'm going to be multiplying that by A naught. What was my initial concentration they gave me on 57? 0.10 molar. 10 times 0.1 is what? 1, right? 1 divided by 1 is 1. So K is equal to 1 liter per, you have to get your units right, moles times minutes. 1 liter over moles times minutes. So that is your K for 57.
How do you know the units?
Well, I have 1 over minutes times molar, right?
Molar is
Molar is mole per liter, and then I gotta flip it.
okay.
So that's how I got the liter on the top, mole on the
It
bottom.
doesn't matter what time it is, like minutes or seconds. As long as you keep it consistent, it's fine.
Whatever you start with is what you end with.
Okay.
So if you start with minutes, you're gonna end with minutes. But it could be minutes squared, could be, right? So just watch your units.
So if you have two minutes on the bottom, that's minutes squared.
Correct. Yep.
I made my mistake of using M for both in the first example of these.
For M for minutes and molar, yeah. That's unfortunate. Yes. Yep, I would accept liter, molar to the -1, minute to the -1. Yes, that's fine. All right. So now I have my K, so I can now put this into the integrated rate law for part A. So part A, the integrated rate law for a second order is 1 over the concentration of A. 1 over the concentration of A is equal to KT.
Wait, which question is this?
This is now part A for 57. I needed to solve for the K first in order to use the integrated rate law. Times KT plus 1 over the concentration of A naught. So, subbing in what we know, this, my 1 over A, do I have my
No.
1 over A?
No. Right? That's what we're trying to find.
Right, so if I'm subbing stuff in here, so my 1 over the concentration of A is equal to my K, which is 1, agreed?
Easy.
I'm just leaving units out at this point, times T, which is what?
80.
80. So I've got 1 times 80 plus 1 over what? Over not 0.01, isn't it 0.1? Over 0.10 molar. So, what?
What's 1 divided by 0.1?
10.
10. So 80 plus 10,
Oh my
right?
No.
So this is saying
I feel that. I feel that though. I still feel it.
it's been a long one day. I figured out we have not had a full week of school since December 17th.
I know.
As it should be.
Yeah. It just,
That's what we like to see.
I don't know. Mondays are hard. We also haven't had a Monday probably since, well, we guess we had a Monday the first and Monday back.
Yeah, we had Monday back. And we had a Friday.
Then we had no school that Friday.
Yeah,
And then no Monday.
and then Monday.
And was there a 2-hour delay that first week too?
Yeah.
Wait.
Yeah.
Oh, yeah, that was a
Has it been
stupid
since we
drive.
came back?
This is our 3rd week back.
Guys, we don't complain about the time of year.
I know.
This is our 3rd week back.
It's our 3rd week back, but so far we've been here like 4.5 days in 2 weeks. You have. Yeah, it's weird.
I've been back like 3 days.
It's so weird. So when you solve for A, concentration of A ends up being 1.1 times 10 to the negative second molar. Is that what you guys had?
Yes.
Okay. For B, you could do all of that again. Right?
I did.
Why?
Because I just plug and check.
But for B, it says 30 minutes. Right?
Yes.
So 30 minutes would be how many half-lives?
2.5.
That'd be 2 half-lives. Right?
40 minutes would be.
Wait.
It'd be 40.
The half-life, wait a second.
10, 20, 40, 80.
So wait, wouldn't 80 be 2 half-lives then?
30 minutes.
80 would just be the 40 half-lives, but
No, it'd be 3 half-lives.
Plug in
They went 10,
40.
20, 40, then 80.
then 80, yeah.
Concentration of
But I
A.
don't think you could have 30 half-lives.
That's a cheat sheet.
You know, I think we're just doing the equation.
My bad.
Half-lives are at 10.
Can we just plug it in and not do a complicated stuff?
I mean, you could just plug it in.
I think you have to plug this one in, right? Like, there's no logic.
Half-lives are observed to be 10, 20, and 40 minutes.
Yeah.
It doubles.
I mean, you could do like the half-life divided
Yes,
by
too.
2. The third half-life divided by. So,
Well, did we ever actually solve for the half-life though?
no.
No.
Uh-oh.
We never actually solved for the half-life, right?
No.
We just use 10.
Because for
Because it was A naught.
second order, it's 1 over K times A naught. K is what?
We have it.
K is 1, right? So my T, hold on.
So it's 10.
We found
T1 half,
Half-life
right?
is 10.
And that changes
no,
other things.
we used
No.
No, we never actually solved for the half-life.
yeah.
Agreed?
Yeah.
Yeah.
We know that it's second order,
Yeah.
So it's
Right?
1 over 0.1, which is
1 over 0.1. So my half-life is 10 minutes. Agreed?
Yeah.
Yes?
Yeah.
So my half-life is 10 minutes.
That's just circling.
Okay, oh my goodness. Just checking, okay?
It's not circling.
So-
It's guessing and checking.
On this, I am at 30 minutes, right?
Yeah, you just plug and
Yeah.
plug.
So what did you guys get for your concentration?
0.025.
Yeah, 0.025.
I have a question.
Yes.
So we solved for K using 10 minutes as the half-life, but if we solve for the half-life using K, but to find K we had to use
Which is why.
Yeah.
our assumed half-life. Could we use any of those numbers for the half-life? Why does it matter if it's 10, 20, or 40?
Oh, we already had the 10 minutes.
Yeah, that's why I said.
How do you
We had that.
Wait, we get that wrong.
I know.
Wait, we didn't use 10 as a half-life.
Can we take
So
this
it's
wrong?
Yeah, we did.
We used it as an initial.
No, we used it as the half-life. 10 and a half is the half-life.
Well, the first half-life is 10 minutes. So it said half-lives are observed to be 10, 20, and 40 minutes.
But you don't need the half-life for the integrated. Right?
You're right, you don't need it. So you're gonna plug and chug the same thing with 30 minutes and get 0.25. So you're gonna do this exact same thing again, and for B, you end up getting 0.25, 0.025, right? 0.025 more. Get 0.025 more. That's probably more complicated than what you even have to do in the test tomorrow. So that's 57, 63. These get easier as we go. I'm going to write this. 63, I have C4 H9Br yields C4 H9 plus Br minus. That is slow, which is key. That's slow. And then this next one I've got C4 H9 plus H2O yields C4 H9 OH plus OH2 plus. That's fast. And then last step I've got C4 H9 OH2 plus H2O yields C4 H9 OH plus H3O plus, and this is also fast. So the first thing it says is write the rate law. Okay? Rate equals K times the concentration of C4 H9 Br. How do I know that? That's a slow step. And that's the reactant.
How many nights?
So how do
Why is it only like?
Yeah.
How
It
is,
has to be the slow step. The slow step only has one reactant.
But how
Why
do we
is
know
it-
it's first order?
why is it?
Huh?
Do we know it's first order?
Yes, because I only have one reactant.
Okay,
What would
yeah,
zero
yeah,
order
yeah,
look like?
Wait, it's first order.
Wait, yeah.
that's right.
What?
What would zero order look like?
You won't have a zero order in one like this. That's integrated rate law.
So if there's two reactants, it's second order.
I mean, it depends if it's a slow or fast step.
So if it's a slow step and it has two reactants, then it's.
Well, you'd have to have two the same, right? Because in order to have C4H9Br2,
Oh,
you'd have to have
then
two of
we-
those,
Oh,
right?
I was just,
So if it's two. Yeah,
That's
two
what
more.
it's.
Correct. Remember, you guys don't get confused between rate laws and integrated rate law. This is not integrated this time,
Because
right?
rate is only about
Correct.
each individual
Yes.
thing. Okay.
which is why I'm glad we're going over this one. Slow step, reactant, that's the rate law.
So it's the first order?
It's first order.
If there was a second reactant in there, would you have to write the rate twice? The rate law twice?
No, I'd write rate equals K, concentration of that times the concentration of the second thing.
Yeah.
Yes.
Wait, so it has
How would you
all
know?
the same rate because like the determining step or whatever,
Slow
so it's
step.
like the same.
Rate determined step. Yep.
If there was 3 moles of that, would that be to the third power then?
No.
No.
No. We don't. Remember, you don't use coefficients.
So,
All right. You don't use coefficients. You always just write down what you have.
so how do you have the second order again?
There'd have to be a second thing in this step. Had to be a second thing.
Like 2 of that?
So 2
Could be. If you had 2 of these. So if you know that this is the slow step and you had 2 of these, then you could, right? In the notes, I say you can't determine from the coefficients
Yeah.
unless you know it's the rate determining step. Then the coefficient then can become.
So we
If not, there'd have to be 2 different things. So yes to both.
so you're telling me,
I am.
2 things? I'm confused
So-
as 2 things.
So Danny is saying if there was a coefficient of 2 here,
Yeah.
If there's a coefficient of 2 here,
Okay.
yeah, that would have been second because this is the slow step.
Okay. If there's a 3 there, would that be?
If there's a 3, there would be a 3, but that doesn't exist.
Okay, that's
All right? Or if there was a second chemical here,
okay. If there's another reactant.
right,
Then
then
it's
there'd be the other reactant, and the overall would have been second. Okay? Okay.
What a great engaged question. You maybe, like, that might warrant a scan.
You're right.
What
Yeah,
a
I need to
great
start
engaged
scanning some
question.
things.
I've done like 9 today.
I
Wow.
think that might.
I wish I was.
Wait, so how is it not even just candy? That
Huh?
question, or is just candy?
Let's finish this. Huh? He has cinnamonies all the time. I don't know where he gets them from.
I didn't see him walk behind.
I don't know.
Where did he
Guys,
come from?
Burger King used to have cinnamonies. Do any of you guys, might not even remember that. It was like a pack of like 4 or 6 in this little pack, and then it came with a little dipping cup of vanilla, like icing. It was incredible.
Wait, what?
When that came out, it was like when I was in college or high school. Cinnamonies. Incredible. Incredible. It was a Burger King thing. They should have kept it.
Oh, is it like
They
how the
always
pizza,
get rid of
pizza
the
has
best
the cinnamon sticks? They also have vanilla dipping sauce.
Yeah, but these were better.
Is it better?
These were better.
I'm more mint.
Question.
Agreed.
When you fly at an airport, is there any airport food you always get?
No.
When you fly, what? I feel like Annie Ann's is one of those things you have to get.
Or Shake Shack.
No?
There's a Shake Shack there?
get-
Okay, there's a Shake Shack there?
Shake
If
Shack.
there's a Shake Shack there, then yes.
You guys got no?
Yes, we live
Nothing?
on-
What do you get? Can of Pringles. Okay. All right. My wife. Shh, we're talking about airports.
Explain what an airport is.
Oh, okay, sorry.
I'm saying like once you get to the duty free area, like after you go through TSA, and
Right.
like that's when you get to the,
Yeah.
yeah.
My wife, for some reason, every time we fly, she buys a magazine. We like never get magazines, but every time we fly, she buys a magazine. So that's her thing. She also lost a $50 bill once at an airport. That was unfortunate.
I think it'd be
You know, one time I found a $50 bill.
I would
All right,
Unrelated.
that's funny. That was good. Okay. Write the rate law. Check. What is the overall balanced equation for the reaction? So I have, let's see, C4H9OH2. So this, I'm gonna circle stuff that's gonna be gone, right?
Yeah.
Yes. This is also gonna be gone, right? Yes.
Yeah.
So my overall equation is going to be C4H9Br plus how many H2O? 2 H2O yields Br minus plus C4H. I can't even read that. Thank you. H9OH plus H3O plus. And the other good news is, what did I just identify by circling? The intermediates. No catalyst.
How do you know if there's something as a catalyst?
Because if there's a catalyst, you have to start and end with it.
Wait, what's the
So it'll be
intermediate then?
here at the start and also at the end.
Wait, what's the
Only at
intermediate?
start, no, only in the slow step.
Correct. Well,
So
yeah.
only slow.
First step, step 1, step 3. Whatever your first step is, last step.
Is the first step
Doesn't
always
have to
a slow
be.
step?
Doesn't have to be a slow step.
Okay, so if it, even if it's a fast step.
Correct. Yes.
So would the intermediate be C4H9OH2 plus or?
And C4H9 plus. There's 2. There's 2 intermediates in this one. Intermediate 1, intermediate 2. It's a scam, I know. But yes, those are both the intermediates. Okay. That was 63. Last one, 67, and a nice little picture. I think I can fit it on this page. 67. I have energy, right? And then I've got basically time down here. So I have a little.
Okay.
Wow.
Wow.
Why I made those sound
Wow.
effects. It says label reactants. There's my reactants. Products. There's my products. The activation energy. Here, that little hump is my activation energy. And delta E, I hate that they use delta E, but they did. That is my delta E, which would be the same as what? Delta H. But they're just saying the change in energy, not specifically heat, but that'd be the same way that you find your delta H. Huh?
I checked my answer to the book and it said the whole from the bottom line up to the top of the was my answer.
Oh shoot, you're right. I think you're right. The activation energy should be from where it starts to the hump. Let me check. I think I messed up. Yes. Yes, the activation energy has to start at the reactants, right?
Oh, that makes, because then it takes that.
Correct. Because the reactants have to get over that whole hump. So make sure you guys fix that. That is your activation
That's
energy.
gotta be worth a scan.
Then what is
Delta E, the difference between your reactants and products. So this one would be endothermic or exothermic? Endothermic.
How do we know?
But it takes the heat to go.
Because the products are higher than the reactants.
And if
It
they're
absorbed energy.
lower-
Right?
So if it's lower, then it's
Exothermic. You got it.
because the product has less. Okay.
What?
Lower energy and, oh, those reactions.
Reactants lower, products higher, it absorbed energy. Endothermic.
So wait, how do we know that the reactants are the ones from the bottom?
That's what you start with. Yeah. Yeah. Reactants are what you start with. Okay. Any other ones you guys want me to show from the beginning? Mostly did all of them.
Jackson
Yes,
had some.
46.
46.
I didn't answer the
Okay, yeah, 46B. I can see why you'd want me to explain that one.
Can you do all of 46?
Unless we don't need to know it. But just
I mean, they're not gonna be able to make that on the task, but I do want you guys to understand it.
dang.
All right, 46. So on 46, I have data, correct?
Yeah.
So they tell me
I'm at 48.
what?
48B.
Wait, did you?
Sorry, Danny said 46.
Okay.
I'm sorry.
All right. So in 46, they tell me that NO2 is excess, right? Why is that important? Why is that important that NO2 is excess?
Because then we know the limiting reactant.
Yeah,
True.
that is true.
But also, its concentration, because it's big, is just going to be constant, right? When it's so big, its concentration isn't going to change. Yes?
You make a good point.
Yes.
Yes. Good argument.
So, good, you recall that. So they gave me an equation here. In one experiment, NO2 was in large excess at a concentration of 1 times 10 to the 13th molecules per centimeters cubed with the following data collected. What is the order of reaction with respect to oxygen? Did you graph 46? Because when you graph it, you will get natural log of the concentration over time as a straight line. So this is first order with respect to O. So it's first order with respect to O.
What does that mean? Respect.
For oxygen.
So this is for oxygen?
Yeah.
Alright, cool.
So when it comes to oxygen, it's first order.
I need this in English sometimes. So.
Okay. I'm glad you asked.
Aiden looking at teacher dead in the face and going, what does respect mean? Coldest line of the year.
What is respect? So we know that. Yeah, never mind. He's not getting scanned today.
He doesn't know what integrity is.
So we know that rate
I don't know how to rise anymore, guys.
equals K times the concentration of NO2 times the concentration of O. And on 46, we were on 46, when I did this, I had to figure out my K. I had to figure out the K from the graph. Right? So when you graph this, you could have determined your K. Did anybody do that? No?
Where did we have to?
I guess, yeah, you don't have to,
Oh, we
actually.
said value.
I mean, you don't have to. You could also just use your first, what? You can just use the first time. So if I'm looking at the second trial, right? 1 times 10 to the second is, oh, wait, sorry, that's 1 times 10 to the negative second. No. 46 off of your graph. K ends up being 100 when you get your slope. From this graph, when you hit your stat plot and figure out your y equals mx plus b, you get 100. Okay? So your k is 100 seconds to the negative first, because it's first order. So that is your k value. That's your k value. So if I wanted to solve for, it says, what's the order of reaction with respect to oxygen? Then determine the overall rate law and the value of the rate constant. So remember, this is only for what? This is only for oxygen, right? So I have to figure out K for the whole thing. Yes.
Did we have to graph it to figure it out it was first order?
Yes. You did.
Because it doesn't decrease at a constant rate, so it couldn't have been zero order. And it's not second because it's going down, right?
You still should have graphed it
Okay.
to make sure. I would graph it no matter what. Okay? Graph it no matter what. Your line of thinking is right, but graph it.
Okay.
Just to check. So to get the overall, I am going to take my 100 seconds to the negative 1. I'm going to set that equal to K for the overall reaction. I don't care about the other one because, oh, they give me. For NO2, that's equal to 1.0 times 10 to the 13th. To the 13th molecules, we really need units here, per centimeters cubed. So the 100 seconds to the negative first is equal to K times 1.0 times 10 to the negative 13th molecules per centimeters cubed.
Why did we set 100 to the rate?
Because this 100 was only for the oxygen, now I have to compare that to the whole thing.
Okay, well, why did you set that to the rate? Why is it the rate?
Because 100 essentially is my rate. Because this one's in excess, the 100 basically becomes the rate.
Oh, because we
Because
said
Oh,
this.
Right.
The other one doesn't have a rate.
Correct. The other one doesn't have any.
So, okay.
So that's why I have to use 100. So now I'm just doing 100 divided by this number, and I have to figure out my units. So once there's a lot of conceptual stuff here. So once I do that, I got K is equal to 1.0 times 10 to the negative 11th centimeters cubed over molecules times seconds. After you do all the weird unit stuff. That was 46. Did I hear 48 as well?
Yes,
Wait,
please.
so
48.
I'm just confused.
Question,
Yes.
how important are units gonna be on the test tomorrow?
We're going to have to solve units for K at least once. I don't care about units in the work. I told second period this. Units in the work on this is not important to me. Okay? If you're solving for a time, I want units. If you're solving for a K, I want units. You can do units later at the end. But I don't really care about units within the work.
But K has to be like the correct units?
Correct. K has to be in the right units.
What are the correct units for K?
Well, if it's, first of all, it depends if it's integrated or not, right? If it's integrated, right, it's going to be whatever it's just going to be seconds, if it was seconds. If it's first order, it'd be seconds to the negative first. If it's second order, it's going to be 1 over seconds.
How do you know if it's integrated or not? If you have a not?
Integrated, you're just going to be like a set of data you have to graph. If it's not, you got to solve for it by plugging in values and dividing all your units.
Okay.
That's how you know how to figure out your units on your. Okay, John.
Are you going to like test this on like 33 like C like dimensional analysis on this stuff?
No.
Okay.
Aw.
I thought that was just really neat.
Yeah, that was just converting units.
Yeah.
And I'm pretty sure I did that one second period. Yes.
Now, how do you find
It's
K if you're using like the slope on a graph?
K is the slope.
Probably what that
Well, like
on
the
the
units
test.
for it.
For the integrated,
Yeah, like you have the number, but you don't know that.
So if it's first, like, okay, so like let's say it is, if it's first order, it's going to be concentration versus time, right? It's just going to be a direct relationship.
There's no way.
So y equal y is, your slope is always y over x, right?
Yeah.
So if it was something like this, it'd be molar per second.
Meters times second.
Yes. If it's natural log, it's always whatever the time is, the negative first, right? If it's second order, it's going to be 1 over concentration time. So that means it's going to be,
Liters per moles per time.
yes. It's just based on what you have.
But it's just 1 over time for.
First order, always time to the negative first.
Okay.
Every time. Easiest way to remember that. Okay, 48. On 48, unfortunately for 48, you had to have done number 47, right?
Oh.
So for 48b, wait, why am I starting with b?
Because that's what we asked for.
Oh, you didn't ask for a.
We'll keep up.
Okay.
Sure. Give up.
The class has spoken.
For 48a, what is the concentration of A after 9 seconds? So in order to do 48a, what was the order you guys got on 47?
Great question.
On 47, you got that it was second order, right?
Yeah.
So it's second order. It's second order. So, did you get your slope from that first one? What did you get for your slope? 20. Should have got 10.
10.
You should have got 10.
That's none of the numbers.
Your graph should have spit out 10.
Yeah.
Should have got 10. So now, using the second order equation, which is 1 over concentration of A equals KT plus 1 over the concentration of A naught. Now I'm going to sub in what I got. So this means that 1 over the concentration of A is equal to, I have 10, right? So 10 times the time, which is 9, yes?
Yeah.
Plus 1 over, what's my initial concentration?
20.
See, this is where it's tricky.
0.1.
What?
0.1.
How did you get 0.1 molar? You're right.
You have
It
to
was
do
the
the
initial-
reverse.
What?
It was the initial concentration we found in 47, right?
On 47, yes, that was the initial concentration that you got on A. So that's how you got that 0.1. That's why you have to understand where this came from.
Why is that one not negative?
Where?
You're really
0.1. I solved it. I just didn't understand.
Why is it not negative?
No, never mind. I actually
Okay.
Eventually.
Concentration of A ends up being 0.01 molar.
If you squint.
So that is 48A. Then, what are the first 3 half-lives for this experiment? So now, I've got to go into my half-life equation. So T1 half is equal to 1 over K times the concentration of A naught, which is equal to 1 over 10 times my A naught was 0.1 molar. So this first half-life gives me what? 1. 1 second. Now, for the second half-life, for T1 half, it's going to equal 1 over 10 times what? 0.1 divided by 2 is 0.05. What?
1/5?
Yeah, that's 1 second. Half of this for the second half-life, agreed?
Oh, okay, yeah.
That gives you 2 seconds. For my third half-life, it's going to be 1 over 10 times, what's 0.05 divided by 2? 0.025. So that is 4 seconds. So you're just taking your molarity, dividing it by 2, because you have half left.
Wait, so this is second order, right?
Correct.
So the length of the half-life is increasing, concentration decreasing?
Yes.
Yes.
Okay.
It's not constant.
Yeah,
It's not constant.
and it's not decreasing.
Yep.
So it's increasing.
Correct.
Always exponential, like
No.
where?
Not always. Not only for second order,
Well,
right?
when it's second order, is it always exponential? to the
Yes.
same rate?
Yes.
Okay, so really, we just need to solve for 1 and know the second order, and then we can do 1, 2, and 4.
Correct. Could have done that too. Okay. Sweet. So, I did the first half. I will post both of those.